In this video, we're going to be evaluating more logarithms. So before you do this, just make sure you're comfortable with logarithms and exponentials. We're going to do a little bit of a review in this video, but those are the basics. All right, so again, really important, I'm going to put this at the beginning of most videos, just to remember what a logarithm is. It's this new function, but it's just the inverse of an exponential. All right, so I can always go backwards and forwards between the two of them as long as input becomes output, output becomes input. All right, to do some slightly more complex logarithm problems, we need to remember all the different types of exponents we have. So the first one we've kind of already dealt with. Positive whole number exponents just means you have that many copies of the number. So x to the fourth is just 4 copies of x. But then we learned about negative whole number exponents. Those are just a shorthand for moving something to the opposite side of the division bar. So here, we kind of have to create the division bar and then move it to the bottom. Here, it would just move to the top, and then the division bar would go away. And then we also have shorthand for roots is our fractional exponent. So if it's just a 1 on the top, that's exactly just the nth root. All right, something we multiply by n times to get x. And if it's a more complicated fraction, we can separate it out into the whole number part and the root part in either order. So we can do the root first, and then the whole number, or the whole number, then the root. All right, so this is all the different types of exponents that we have learned. And now we want to use those to our advantage. All right, 16, log base 16 to 2. What is this going to be? Again, remember this is asking the question 16 to what exponent equals 2. This is definitely not going to be a positive whole number answer because 16 to the first is 1. 16 squared, 16 squared is 256, I think. Bigger numbers. So as I put in bigger numbers here, I'm going to get bigger number. So it's definitely not a whole number. It's not going to be a negative number because if I do a negative number, I'm going to do, oops, that's not what I wanted. Get fractions, and my answer is not a fraction. All right, so my only other option is there's fractional exponents. So I need to figure out what fraction am I going to put here. And one way you can think about this, when you're trying to get a smaller number out, you almost can like change the problem around. 2 to the what equals 16? All right, this is a slightly easier question to kind of build up the small number to the big number. So 2 to the fourth equals 16. Again, just double check 2, 4, 8, 16. All right, so 2 to the fourth equals 16. So we want to switch it around to the other direction and do the opposite of the fourth power, and that's the 1/4 power. All right, so 16 to the 1/4 kind of is the opposite of 2 to the fourth. And that tells me this answer is 1/4. Okay. All right, so this is kind of my one piece of advice here. If you're trying to go from a big number to a small number, kind of think about it in the other direction first, figure out the whole number, and then the fractional exponent is just the opposite. All right, 5 to the 1/25. So there's one thing you should instantly see here is that I'm starting with 5, I'm trying to figure out what exponent to give me 1/25. If I'm going from a whole number to a fraction, the only way I can do that with an exponent is to make it negative, because we know negative exponents make things into fractions. All right, so right away I know this answer is going to be a negative number, so I could try -1. That gives me 1/5. I could try -2. That gives me 1/5 squared, which is 1/25, which is exactly what I want. So the answer here is -2. All right, the negative makes it a fraction, and then 5 squared is 25. All right, but that's just another thing. If you see you're going from a whole number to a fraction, you instantly should know that your exponent is going to have to be negative, because it's the only way with an exponent you can change something into a fraction. All right, so here are some things that are going to help with evaluating logarithms. If I'm trying to get a number smaller than the base, all right, I'll think of roots, and I know my answer will have to be a fraction. All right, that's 16 to the 1/4 equals 2. If I'm trying to get a fraction, I'll know I need a negative exponent, so my answer will be a negative number. All right, so now we're just going to rattle off some more examples that we have that kind of idea. Here I'm trying to get a fraction, so I know my answer is going to be negative. And then 10 to the -1 would just be 10, -2 is 100, -3 is 1,000. So my answer is -3, 10 to the -3 is 1/10 cubed, which again just means I have 3 zeros, exactly what I want. Log base 64 of 4. All right, so 64 to the what equals 4. All right, again, going from this big number to the small number sometimes is hard. With enough practice, you can do it. But I like to think about, okay, 4 to the what is going to give me 64. All right, 4 squared is 16, 4 cubed is 64. So 4 cubed is 64. I need to reverse that. 64 to the 1/3 will get me back to 4. All right, so again, thinking about it from the small number to the big number will kind of help you get your answer. All right, so here's one for you to try on your own. Evaluate log base 4 of 2. All right, so I'll show you the answer in 3, 2, 1. And the answer is 1/2. All right, 4 to the 1/2 equals 2. How do I know that? Well, the square root of 4 is 2. That's one of the more easy squares. But another way you can double check that is 2 squared equals 4. All right, those are the opposites. All right, so here's some more challenging problems. All right, so if you want to try these, go ahead and pause the video and try them and see if you can come up with the answers. All right, I'll kind of go through them. All right, it's up to you. You can pause them, try them, and I'll go through the answers now. So this first one, I'm trying to find 25 to the what equals 1/5. So two things are happening here. One, it's trying to go to a fraction, so I know it's going to be a negative answer. And two, 25 is getting smaller into 5, so I know it's also going to be a fraction. So I got a negative value here from the fraction. I'm going to get a root of I keep saying fraction and negative interchangeably. I got the negative because it's going to a fraction, and I'm going to, because it's going to a fraction. Okay, yeah, that makes sense. And then I'm going to get a fraction for my answer because 5 is smaller than 25. So how do I go backwards from 25 to 5? I have to do a square root, which is the 1/2 exponent. All right, so I feel like I messed up that explanation. So let's explain it again. So 25 turning into a fraction, my answer has to be negative. 25 turning into a 5, a smaller number, my answer has to have a fraction in it. So those are the kind of two parts that are coming together to make this answer. All right, 1/3 to the 1/9. One mistake you might make in this one is thinking that you had to have a negative because you have a fraction here. The only difference, the reason this one does not have a negative here is because you started out with a fraction already. So we have 1/3 to the what equals 1/9. All right, we can kind of just look at the bottom. How do we get from 3 to 9? We square it. So this is just 2. All right, so this one's kind of, there's a challenge problem because it's not a negative answer because you already started with a fraction. All right. Another thing you might have is like log of 1/3 of 3. What would this be? Now you're going fraction to a not a fraction, so that's where you'd actually get a negative value. The answer there would be -1. Log base 14 of 0. 14 to the what equals 0. All right. And you might try some things. Any positive number is just going to give you a bigger number out. Any negative number will give you a fraction. Any root's just going to give you some like decimal. So this is pretty hard, and the reason is this is not possible. And this is something we'll learn shortly. But you can't plug 0 into a thing because I can never get 0 out of an exponential, which means it can never go into a log. All right, so those are some extra types of problems for you to see if you're interested. Main things, all right, make sure you know your exponent rules for whole numbers, negative, and fractional exponents. If you know those, you're just doing them backwards to figure out these. And again, always just double check your answers really quickly to check to make sure that your exponent actually works. We can do exponents a lot quicker than logarithms, so just spend that little bit of time, check your answer to make sure you got it right.